Welcome back to Security for Legal SaaS. I'm Alice.
And I'm Dan. Episode 45, Docker Security and Container Hardening. We're starting a new module today, Module 10, Infrastructure and Deployment. Alice, containers are everywhere in modern software, but I suspect most of our audience hasn't thought much about what they actually are.
Let's fix that. A container is like a sealed shipping container for your software. You pack everything your application needs to run inside it. The code, the libraries, the configuration, and it runs the same way everywhere. On a developer's laptop, on a test server, in production. That consistency is why containers won through Docker. Your legal SaaS platform, whether it's a contract review tool or a case management system, gets packaged into one or more containers, and those containers get deployed to your servers.
Right, and that sounds great from a reliability perspective. What's the security concern?
The concern is that containers are not virtual machines. A virtual machine has its own entire operating system, fully isolated from the host. A container shares the host's operating system kernel. That means a vulnerability in the kernel can affect every container running on that host. NIST's Container Security Guide, SP 800 to 190, puts it directly. Containers provide less isolation than virtual machines. A container is not a security boundary.
So what is it then?
A useful speed bump. A well-configured container limits what an attacker can do if they compromise your application. It's not the wall. It's one layer in your defense in-depth strategy, which we covered in episode 4. The keyword is well-configured. An out-of-the-box Docker container with default settings is convenience optimized, not security optimized. You have to actively harden it.
Okay, where do you start?
Base images. Every container starts from a base image, a template that includes the operating system and core libraries. The most common mistake is using a full operating system image like the standard Node.js image. It contains over 900 packages. 900 pieces of software, most of which your application never uses. Every one of those is something that could contain a vulnerability. Switch to a minimal image. Alpine Linux-based images have around 30 packages. That's 870 fewer things that can go wrong.
Yeah, that's a dramatic difference. What about the version? I see a lot of tutorials using things like node:\latest.
The latest tag is a moving target. Today's latest is different from last month's. Your build is not reproducible. You cannot prove what was in that image when you deployed it. The fix is to pin by digest. That's a cryptographic hash of the image contents, like the SHA-256 fingerprints we've talked about before. A digest never changes. If you deploy with a pin digest, you know exactly what's in that container, and you can prove it to an auditor 6 months later.
Okay, base image sorted. What's next?
Running as non-root. This is the single most impactful security change you can make. By default, processes inside a Docker container run as root, the most powerful user on a Linux system. If an attacker exploits a vulnerability in your application and manages to escape the container, they inherit root privileges on the host. They own the server. The fix is 2 lines in your Docker file. Create an unprivileged user and switch to it. Now, if the attacker escapes, they land as a nobody user. Still bad, but dramatically less catastrophic.
Right, that's the principle of least privilege from episode 8. Give the process only the permissions it actually needs.
Exactly. And you can go further with 3 more hardening layers. First, read-only file systems. Mount the container's file system so nothing can be written to it. An attacker who gains code execution can't plant malicious files, can't modify binaries, can't install tools. You provide a small writable temporary directory in memory for logs and temp files, but everything else is locked.
What's the second layer?
Dropped capabilities. Linux breaks root's all-or-nothing power into individual capabilities, like binding to low-numbered ports, or loading kernel modules, or changing file ownership. Docker gives containers a default set, but most applications need almost none of them. The CIS Docker benchmark, That's the industry standard security configuration guide from the Center for Internet Security. Recommends dropping all capabilities and adding back only the specific ones your application requires. Most web applications need 0 special capabilities.
And the third?
Seccomp profiles. Seccomp, secure computing mode, restricts which system calls a container can make. System calls are low-level requests to the operating system. Open this file, create a network connection, allocate memory. Docker's default profile blocks about 44 dangerous system calls out of 300 plus available, things like reboot and mount. For higher security, you create a custom profile that allows only the specific calls your application uses. Everything else is denied.
Huh. So you're stacking these non-root, read-only file system, dropped capabilities, seccomps, each one independent.
4 independent barriers. An attacker who gets past one still faces 3 more. That's defense in depth applied to container configuration.
Makes sense. Let me ask about secrets, database passwords, API keys. Where do those live in a containerized world?
Never in the image. This is a hard rule. A container image is a static file. Anyone who gets access to it through your container registry, your CI/CD logs, a developer's laptop, can extract every secret embedded in it. Secrets must be injected at runtime. The simplest approach is environment variables. Your orchestrator passes them in when the container starts. Better is mounting secrets as files from a secrets manager. Best is having the application fetch secrets from a tool like HashiCorp Vault, which we covered in episode 15 at Startup. With Vault, secrets are short-lived, automatically rotated, and every access is logged.
And scanning. How do you know if your container image has vulnerabilities?
You scan it. Tools like Trivy, Gripe, and Snike Container analyze every layer of your image against vulnerability databases. The important thing is when you scan. Most teams scan during the build process, which is good, but they forget to rescan running containers. A base image that was clean last month might have 3 new critical vulnerabilities today. You need continuous scanning. Block critical vulnerabilities from reaching production. Set deadlines for fixing medium ones, and rebuild your base images at least weekly to pick up security patches.
Right. And there's an automated audit tool for all of this.
Docker Bench for Security. It's an open source script that checks your Docker installation against the CIS benchmark. Over 100 configuration items. Host settings, daemon configuration, container runtime settings, image best practices. Run it regularly. Treat failures as security bugs. For a legal SaaS platform where you have professional obligations around data protection, ABA rules, SOC 2, potentially GDPR, a clean Docker Bench report is evidence that you're doing your due diligence on infrastructure security.
Good overview. Next episode, CI/CD pipeline security, the system that builds and deploys all of this.
Your CI/CD pipeline has production credentials and runs arbitrary code. It's the most powerful system you own. Next episode, we'll talk about treating it that way. Until then, I'm Alice.
And I'm Dan.
Security for Legal SaaS is a series written with AI assistants. Alice and Dan are AI-generated voices. No professional advice here, just education.